catch up if they want. If they so desire. So yeah, let's just cruise ahead. We'll do 16.2, which is addition and scalar multiplication. Matrices, let me make a note of them. They are, you can add matrices together. You can subtract them, but they're not commutative. For multiplication. They are for addition, but not for multiplication when we get there. So you can swap them back and forth for addition, just not multiplication. We talked about the zero matrix. Maybe I'll do an example, but if you have like 5 plus 0, what's 5 plus 0? 5. So if you have a matrix plus the zero matrix, it'll stay itself. It won't change anything. So that's normal. If you have like 6 plus a negative 6, you get out 0. So a matrix plus its additive inverse, if you will, the opposites, it'll end up being the zero matrix. Scalar multiplication is the same thing as like distribution, except it's not with parentheses, it's with the matrix, and I'll do an example of that. But scalar multiplication, really the same thing as distribution. So let's just do a few, this is 16.2, which is addition, and then scalar multiplication, which is essentially, like I said, distribution. Let's just do some examples here. Now, if I have a, let's say a 3, negative 4, 1/2, 0, 5, negative 14. If I have a, well, what are the dimensions of this? I should ask you.
2 by 3.
Yeah, 2 by 3. So if I have a 2 by 3 and I want to add it to something, what am I going to have to add it to? Would you guess? Yeah, it's going to have to be added to a 2 by 3. Now multiplication is a little bit different, but the 2 by 3 has to be added to a 2 by 3, so I'll pick some numbers here. So when you add a 2 by 3 to a 2 by 3, you're going to end up with not a 4 by 6, but you'll just end up with a 2 by 3. So when we go to add, you simply take your elements and match them and add them or subtract them depending on the numbers. So 3, row 1, column 1 is going to be added to row 1, column 1. So 3 plus 0 is 3. And then negative 4 plus 5 is 1. 1/2 plus 5 halves is 6 halves. So 3. 0, negative 1 is negative 1. 5 and 0 is 5. And then negative 14 is 0. And there would be your answer. So that's the basics of addition. This is commutative. If I took this and swapped it over here, put this over there, you'd add them together, you'd get the same answer. Okay, so then scalar multiplication, let's just do one like this. If you have 7 and then like 2, 0, negative 1, and whatever, 5/9, we'll throw a fraction in there. So the 7 on the outside represents multiplication. It's 7 times that. Again, scalar. This is called scalar multiplication because it's not a, since it's with, you do this with vectors and with matrices, you call it scalar multiplication, but essentially it's distribution. So the 7 is going to multiply to every element on the inside. So 7 will go to 2, 0, negative 1, 5/9. So essentially distributed in there. But you call it scalar multiplication. So 7 times 2,
14.
7 times 0, 7 and negative 1, and then 35/9. Okay, I'll just leave it as such. It probably won't give you too many fractions, but that's what it would be. All right. Let's do this. One more. Solve for matrix X. if you have x minus matrix 0, 5, 1, negative 2, 0, 5, 1, negative 2 equals 3, that's 2, negative 3, 3, 1. So what you want to do is you just look at matrix X, and then if you want to solve for it, you figure out what's attached to it. And you have a negative matrix, right? Or minus a matrix. So just like you would solve any other problem for the variable, how would I get rid of this matrix? Bring it to the other side.
So, would you add it?
Yeah, sure. If it's being subtracted, you just add it to the other side. So then x is equal to, now what I do here is I do the multiplication, the scalar multiplication first, and then add it. So you'd have a matrix plus a matrix. So you'd end up with 6, negative 9, 9, and 3, 0, 5, 1, negative 2, 6, negative 4, 10, and 1. And done. There we go.
That's it?
That's it. Yeah, that's really the basics of it.
Cool. I don't know, I think I got my Bible, not my math book, but how did I miss that? Bible, math. Bible, math. Oh. It's complicated.
Okay.
Okay, I gotta switch out my
7-minute lecture.